you see Worksheet 1E, internal shear force and shear stress. For the steel lap joint is held together by a single 1-inch bolt. So 1 inch, it means that is the diameter of the bolt. Determine the shear force acting on the bolt and the corresponding shear stress. So as you can see, is there are two steel plate here, A and B, and those two have two load. 7 kip tend to separate the bolt, cut the bolt, and that create a shear force. So let's draw the free body diagram for the bolt. Free body diagram for the bolt. Free body diagram of the bolt. And in this case, it's a single shear. As you can see, one cut for the bolt. What is single shear or double shear? You can go back to the lesson note part 3 to have the difference between single and double shear for this scenario. So with that, we can draw the bolt, and in this case, let's put it vertical. Bolt. And it tend to cut make one cut through the bolt. And the top have a steel plate 8, make a force go to the left, 7 kips. And the bottom B, plate B, have 7 kips go to the right. So that, and you can see free body diagram for the bolt. And now the question asks, determine the shear force acting on the bolt. So as you can see, we have to cut the bolt. Cut at the blue section here. Cut at the blue section here. So we can have for the internal shear force. Cut through the bolt, and you can either consider the top or the bottom of the cut. So let's consider the top. Then you can have that member here and the cut like that section. And the top have 7 kips still go to left, and with that, as you can see, the shear, internal shear on that cut cross section, that blue here, and you can see it will go to the right, and that is V. And if we consider the X and Y in that case, then if we sum up all the forces in X direction, go to the right is positive, so we have V minus 7. So from that we have the internal shear force V equal to 7 kips. To be more specific, the direction it will be go up on the go to the right on the top portion of the bolt. So when you have the shear force, you can go ahead to find out the shear stress. And the shear stress by equation is tau and equal to the shear over the areas, shear force over the areas. In this case, the bolt is 1-inch bolt, so you can go ahead to find out the areas. Area of the bolt A equal to, the bolt is a circular cross section, so P D square over 4, plug in pipe D square over 4, so pipe times 1 square over 4, so that you will get 0.785 in square. So from that we can plug into this equation. We have 7 for the shear force, 7 kips divided by 0.785 square inch. So we will get 8.91 kips per square inch. So it will be a KSI. And that should be the answer for this problem. So bottom line, as you can see, to find out the shear stress, we need to find out the shear force, and we need to know that joint, that bolt, whether it's a double shear or single shear. What is double or single shear? Go back to the lesson and part 3. Review on that, because that the shear stress will be different. And then you get the areas and get the internal shear force, divide, you will get the shear stress tau. In this case, 8.91 KSI.